8, הטלוויזיה הטובה ביותר בעולם. במשך שעה אחת. שעת ה-BBC, טלוויזיה מצוינת, שני עד חמישי ב-9, ערוץ 8 שווה כל רגע רק ללקוחות הכבלים. אוקטובר 2000, בעדי עזה. מימין מחנה הפליטים אוצרות, משמאל ההתנחלות נצרים, ובצומת ילדים בני 18. חייבים לבצע את המשימה.
נוצר מצב שאנחנו באמצע 360 מעלות מסביבנו, יורים עלינו.
אחר כך הם ישאלו למה.
בינתיים היה מקום מאוד מאוד יפה שנכנסנו. נשאר שם כלום כשיצאנו.
הצומת, סרט השבוע, בקרוב. ערוץ 8 שווה כל רגע רק ללקוחות הכבלים. שקוע בחרה של עצמך?
דקלה.
מחפש אהבה שתרים אותך?
איך אני יכול להיות עם מישהו שלא בוחר אף פעם? אני פשוט משתגעת.
כולנו היינו בסרט הזה.
אתה הולך את הצורה עכשיו כמו שבחיים לא אף בחורה, אתה מבין? יאללה, תגיע לגן עדן.
טוב, אני חושב.
על פי רב המחר, חוכמת הבייגלה, סרט השבוע בהום סינמה.
Have you ever considered becoming a member of Parliament?
הוא יילחם בפשע, הוא יגן על החי והצומח.
This is good shit.
יפעל למען זכויות אנשים. הצביעו עכשיו.
Respect.
אלי ג'י, עכשיו בהום סינמה.
מילאתם כבר את שאלון הטלוויזיה הגדול במדינה?
היפנים האלה שעושים תחרות
יא, תחרות יפנים כאלה?
שדרנים שצועקים יא חלאו, איזה גול.
חסר לי ערוץ ייעודי שילמד הישרדות.
אם גם אתם רוצים להשפיע ולזכות בהטבות, לחצו אחת בשלט הדיגיטלי או ייכנסו לאתר.
The heat of the sun drives our weather, but water creates its many different faces. This is a journey with water around the planet, from the oceans to the clouds, from a storm to a flood, to witness the awesome power it can unleash. Intrepid adventurer Donal McIntyre is going to experience the worst it can get. We will also meet some of the people who've been at the mercy of some of the wettest, wildest weather on Earth. We live on a water planet. 70% of the surface is water. Every living thing, including us, is made of it. Right now, there are 12,000 billion tons of it, literally hanging above our heads. And it's this that fuels the world's weather. If you were to divide it by the amount of people that live on the planet, this is how much each single one of us would have. A cube of water measuring 46 meters high, wide, and deep. This would be your share of the water we depend on every day, the same water we bathe in, that we drink or flush away. It's the same water that rains on us, that forms the hurricanes and the monsoons. It's the same water that's been here since the earth was formed. If all things were equal, this would be your share of the weather. We are going to follow the cycle your bit of water takes around the world. Along the way, we'll see how it transforms itself into every kind of weather on the planet. The journey with water begins in the wettest place in Western Europe. Bergen, city of rain on Norway's western coast. It rains here 2 out of every 3 days. What you need here is umbrellas, lots of them.
We have some special umbrella for little rain, lot of rain and storm.
The city is so proud of its rain, they can it and sell it to the tourists, because they've got a lot of it. And to demonstrate just how much they have, if you were to stand under this waterfall for 16 years, you still wouldn't be able to experience the amount of rain that falls in Bergen in a single year. Each month, 18 tons of rain falls on the average family house. That's 225 tons a year. The kids may like it, but other devious tactics have to be employed to keep the adults happy. Enter the blonde. This is TV2, Bergen's local television station. Benedict Rasmussen has the unenviable job of presenting the weather.
It's not that difficult, actually, because when the meteorologist is saying something very long and very difficult, it's probably just going to rain. The longest period of rain was in 1990, and I know this because I've checked it now. But it turns out that it was raining from the 3rd of January to the 26th of March that year. And that's about 83 days. And I can't remember, but I think I was quite fed up of rain after those days.
So why is this place so wet? Day after day, warm, moist air flows in from the Atlantic, hits the surrounding coastal mountains, and is forced up. As it rises, it cools, and the result is rain. Tons of it. Right this second, 18 million tons worth of rain are falling somewhere on the planet. And if all this rain from the rooftops is going to join it, there is only one way it can go. Yesterday, this river was a rain shower in Bergen. Before that, it could have been a monsoon rain cloud over India, or even a cup of tea from the Ritz. Today, it's a river in Norway. By tomorrow, it will have joined the North Sea. And then, who knows where or what it will next become. All this water racing out into the North Sea is about to join a vast weather-making ocean current. This current creates some of the wettest, wildest weather on Earth. But in order to see where this current starts, we have to travel north of Bergen. There are many currents in the oceans around the world, but there is one, a master current, that's the drive belt of our weather systems. It starts here, and it's called the thermohaline conveyor. Every ocean in the world is connected by the conveyor. It's a 70,000-mile round trip that takes about 1,000 years to complete. And in that time, the water could have been part of every kind of weather in Scotland or on the Serengeti. It takes a phenomenal amount of energy to drive this massive engine, the thermohaline conveyor. So what turns it on? What kick-starts it? The secret lies under the ice, and there's only one way to see it. At -2 degrees Celsius, seawater begins to freeze. But this ice is made of fresh water because salt doesn't freeze and is locked out in the process. So the water below the ice is very salty, which makes it heavier, so it sinks. As these billions of tons of cold, salty water fall, they begin to flow south. This sucks the warmer tropical waters up north to replace them. This action drives a permanent ocean cycle. From here, the route it takes is truly global. As the cold waters plunge to the depths of the ocean, they flow along the bottom and then around the Horn of Africa. And after about 500 years, it begins to warm up. The conveyor's first stop is in the Indian Ocean, and much later in the Pacific Ocean, where the whole system then curves around and the cycle repeats itself. As it flows from warm to cold, it creates all types of weather around the world by warming or cooling the air above it. It's hard to imagine that the next time anyone sees this water will be when it rises as a warm current and laps a beach in India. After a 6,000-mile journey within the conveyor, the water that fell as rain in Bergen over 500 years ago is about to become part of the biggest rainstorm on the planet. India hasn't seen a drop of rain for months. Life is almost unbearable. But the weather is about to change. The monsoon is on its way. The biggest rain cloud in the world is about to rush in from the sea. In order to understand how it works, we have to get into the clouds. On a day like this, 75 billion tons worth of rain clouds will sweep across this coast, and a third of that will fall as rain. Some of these clouds can be 10 miles thick and densely packed with water. So what turns all that water vapor into raindrops? Let's take a closer look. Up close, a cloud is just a swirling mass of water vapor. Floating within it are comparatively huge particles of dust and pollen. The vapor is attracted to the surface. It takes billions of molecules to make a droplet. They collide with each other, getting bigger and heavier. It takes 1 million droplets to make a raindrop, only 2 millimeters wide. Gravity does the rest. monsoon downpours are epic. In just a few seconds, they can bring inches of water crashing to the ground. For this brief period in the year, the monsoon changes everybody's life. A welcome relief from the tensions caused by the scorching heat. When the rains arrive, India relaxes and goes mad for football. The rains soften the pitches, making them easy to play on. All this rain can actually make you feel good. As water falls through the air, be it heavy rain, a waterfall, or even a shower, tiny particles in the air called ions become negatively charged. This makes them sticky, which cleans the air by literally dragging dirt and dust particles to the ground, leaving it fresh and clear. The cleaner the air, the quicker the oxygen is delivered around the body, and it's this that makes us feel good. Which is why the shower is where most of us have our best thoughts. All this clean air and staying indoors also produces something else. Lots of water babies. 9 months after the monsoon, the birth rate leaps. It's an intense period because in a few months' time, those monsoon breezes rushing in from the sea will reverse themselves, leaving just the merciless heat of the sun. India only manages to hold on to 10% of all that rain. The rest leaves the country by the thousands of rivers and streams that break its shores. Every second, billions of gallons pour into the ocean to rejoin that great weather maker, the thermohaline conveyor. The cycle continues, this time back towards the Atlantic. The warmer surface current takes only 50 years to get there. It's now about to become clouds in the USA. But this time, they won't bring any rain. This is Texas, land of big skies, and looking at the crops around here, you'd think big rain. In fact, it doesn't rain nearly enough. So the question is, can you make rain? This is Hondo Air Base in Texas, home to Weather Modification Incorporated, one of the largest companies in the rain-making business. It all started in the Second World War, when through a strange set of circumstances, scientists discovered the key to how raindrops formed. At the time, they were trying to solve the problem of airplane wings icing up. In the 1940s, scientists working on this problem in a cold room replicated the temperatures found at high altitude. At minus 78 degrees, the temperature was similar to those high up in the clouds. It was then that the scientists made an interesting discovery. As their breath touched the dry ice, it produced ice crystals that were exactly the same as the ones that form naturally high up in the clouds. They are the frozen seeds of a natural raindrop. This chance discovery led the scientists to wonder, if they put man-made crystals that imitated the ice into the cloud, would the cloud produce more rain? Jeremy Price has been a company pilot for over 4 years.
We can keep a storm going about 25% longer. That's about 5 minutes or so, actually. The actual storm cell will last about 20 minutes before the next one takes over.
And what kind of difference would that make to a farmer?
It has a dramatic impact on the farmer in that we actually increase the average rainfall per year by a couple inches. It doesn't seem like a lot there either, but when you figure how many millions of acres that's spread over, it actually adds up to billions and billions of gallons of water.
Okay, Seed 1, it looks like from your location, area 135 at 20 from your current position.
135 at 20 miles, roger that. What we do isn't magic. There's a lot of science behind it. We're not rain creators. We don't bring rain out of nowhere. What we do is we go up and seed the rain that's already there and make it a little bit more. Around here in Texas, usually in the afternoon, we'll start getting some pretty heavy thunderstorms, and we'll go up there and find through the main updraft. That's where our chemical has the most effectiveness. And as we go in, we'll look for inflow, which is basically an updraft. The storm is sucking up air and feeding itself moisture. And what we do is we light our burners to produce dust in this air that's being sucked into the thunder cloud, and this is what seeds and creates the rain.
The burners release a chemical into the air, which is then sucked up by the storm.
I'm going to reach across to here and turn on the left burner, and a burner's lit.
The process is known as cloud seeding, and the seeds are tiny particles of silver iodide that mimic the shape of the ice crystals. When these particles are sprayed up into a cloud, water vapor freezes onto them. They grow in size until they become snowflakes. As they start to fall back down, they melt into rain. Even if it does rain after the clouds have been seeded, skeptics ask, how do they know it wouldn't have rained anyway? The rainmakers are shrewd enough not to claim that their techniques work beyond a shadow of a doubt, but they provide a service that many satisfied customers are happy to pay fistfuls of dollars for. It's ironic to think that hanging trapped in the blue skies above is all the water they would ever need. Just south of here, the people of the Caribbean witnessed the deadly power of one of the biggest rain machines on Earth. This one had a name: Hurricane Mitch. Mitch was born on the 21st of October in the warm waters near the equator. The sun heats the surface of the sea, evaporating 1 trillion tons of water into the air each day. So once in the air, where does it all go? At about 2,000 feet up, water vapor cools and condenses back into tiny water droplets. This is the dew point. It's where all clouds are born. Each single cloud is made up of billions and billions of water droplets. Carried aloft by the rising warm air, they billow upwards. If the heat from below is strong enough, they grow into massive tropical storms. The 22nd of October 1998 began as a normal day. At the National Hurricane Center in Miami, it was a day they would never forget. Way out in the Caribbean, a major storm system was building.
It developed quite fast after it became a tropical storm. For several days, we were monitoring this cluster of thunderstorms in the air and in the Caribbean, but we knew that it was going to be a threat somewhere in the Caribbean.
In the capital of Honduras, Tegucigalpa, people were oblivious to the gathering storm out to sea. It was hurricane season, and this part of the world is used to it. As it spun towards Honduras, sucking up vast amounts of water, the wind speeds picked up. At 75 miles per hour, Mitch officially became a hurricane. It was picking up 2 billion tons of water vapor each day, which inevitably has to fall somewhere. On the 27th of October, it was business as usual in the capital.
We were in direct contact with the forecast office in Honduras, Nicaragua, Belize, Central America, and in fact, the hurricane was so large that we knew that it was going to affect with rain and strong winds all the north coast of Honduras. So the warnings were up like 20 hours in advance.
The next day, Hondurans began to prepare for the worst. Out at sea, the warm waters of the Caribbean fueled the cycle of evaporation and rain. By now, Mitch had been rated a Category 5 hurricane, the most lethal on the potential damage scale. In Tegucigalpa, Pedro Funes and thousands like him were on their way to work. By the evening of the 29th of October, Mitch had already reached the northern coast. The wind was strong, but the water it brought was deadly.
In this case, the destructive power now is contained in the very, very heavy rains that are being released as the circulation interacts with a very mountainous landmass here, Honduras and Nicaragua down here, and it draws in moisture both from the Pacific Ocean and from the Caribbean Sea, from both sides, and the circulation is so large that it's very slow to spin down.
Mitch was so big that while its center covered the land, its spinning edges sucked up vast amounts of water vapor from the Pacific and the Caribbean. It then poured it straight back down again onto the land.
And so the real disaster is really yet to come in terms of the mudslides and the very great catastrophes that occur as a result of several feet of water being deposited over the mountainous terrain here.
The water racing down from the mountains was funneled into the valleys at terrifying speeds, wiping out anything in its path. Residents watched in horror as friends and neighbors were swept away, along with whole neighborhoods. In the capital, Tegucigalpa, mudslides washed whole shantytowns into the river. One of those houses belonged to Pedro Funes, and this is all that's left.
You could hear people crying. People began to scream. It all happened so quickly. However much you wanted to take some kind of action, it was very difficult. We were almost on the edge of the cliff.
When the cliff collapsed, Pedro lost his entire family. By the 31st of October, Mitch had disintegrated, and the remnants moved away out into the Gulf of Mexico.
The hurricane is both a miracle of nature and it's a monster. When the meteorologist looks at it from afar, he admires it as a thing of beauty and something that I think a lot of people would look at, even non-meteorologists, and say, wow, that's something really spectacular. But at the same time, we recognize that the more beautiful it looks, probably, the more potentially destructive it's going to be.
From the rubble of his home, Pedro was only able to find one body, that of his youngest son, Javier. On a quiet hill above the city, survivors pay their last respects.
Quiero pedirte pues que
un día Dios me lo dio.
Mitch was the most lethal storm in modern history. Over 7,000 people killed, 8,000 missing, and over 12,000 injured.
The death toll in this hurricane ranks with the deadliest hurricanes of all time. This was certainly a very, very catastrophic event, and one that we hope will not be repeated.
An entire country had very nearly been wiped out by one of the most powerful hurricanes the world has ever seen. When it was over, billions of gallons of water drained away into the Gulf of Mexico. Having brought destruction to Central America, this same water is now about to become a key source of the weather in Britain and Europe. And this coconut could be rolling onto a British beach. To understand how, we have to join perhaps the most famous part of the thermohaline conveyor. Drawn out of the warm waters of the Gulf of Mexico by the thermohaline conveyor, the Gulf Stream runs practically the entire length of the North American coastline before reaching out east across the Atlantic. It's 10 degrees Celsius warmer than the sea around it, so it heats the air above it. All that moist, warm air is then picked up and carried with the westerly winds to Europe. We've known for centuries that the Gulf Stream exists because the evidence is washed up on beaches like this every day. Nick and Jane Dark are professional beachcombers and regular visitors to Cornwall on Britain's south coast. After each storm, you'll find them searching along the high tide mark.
Hello.
Hi. These are seeds which we found.
And where's this from?
From Central South America. It probably grew in one of the rainforests, came possibly down the Amazon into the sea.
The Gulf Stream even brought them a little piece of Honduras.
6 months after Hurricane Mitch, we had an enormous number of seeds washed in, particularly on this beach, between 400 and 500, all different species, which had all come up from Central South America on the Gulf Stream.
Everybody's at it.
We get lobster tags from Newfoundland, from Canada.
This one from Newfoundland, which we know took 14 months to cross.
American lobster fishermen date and locate their tags, which helps Nick and Jane form a complete picture of how long it takes the Gulf Stream to carry them to Europe.
You can see the year, 99, lobster, Newfoundland, and the serial number. And from the serial number, we're able to trace the fishermen.
Some of the tags have their telephone numbers, so I phoned them up. And we tell them, you know, that a bit of their gear has come from their side of the Atlantic into ours. And they're all always absolutely amazed.
The warm air the Gulf Stream brings makes the winters in Britain and Western Europe relatively mild, considering that this beach is on the same latitude as northern Canada. Without the Gulf Stream, British winters would be far more severe.
It was very cold all day Sunday.
It does look like it's going to be pretty wet across southern areas, but for northern parts it'll be dry, bright, with spells of sunshine. That's it. Thank you, Jeremy.
But the warm, wet air that the Gulf Stream brings makes forecasting the weather highly unpredictable. In October 1987, a senior British weather forecaster was badly caught out.
Earlier on today, apparently, a woman rang the BBC and said she heard that there was a hurricane on the way. Well, if you're watching, don't worry, there isn't.
But later that night, hurricane-speed winds gusting at over 90 miles an hour did indeed strike the south of England, causing serious damage. British skies can produce some world-class weather. and occasionally some world-class weirdness, as Derek and Adrienne Haythorne-White found out one night at home in Accrington in the north of England.
It was just a normal night. It was fine. Nice starry night. And there was no wind, no rain. And then I heard this thudding sound, like someone was shoveling up in the garden or something.
You know.
And then I went to the back door, opened the back door. To my amazement, I saw these like giant balls coming from the sky really fast. I couldn't tell what they were. I thought, well, too big for hailstone or anything like that. I told him, I said, it's raining apples or something. Something's funny going on.
And they were apples, hundreds of them.
We're starting to see the garden absolutely littered, I mean littered, over ankle deep in apples, all sorts of apples. They weren't just one type. When we examined them, there were Bramleys, Coxes, Granny Smiths, Russets, all sorts, all kinds of different apples.
The only plausible theory about the Accrington apples is that they were sucked up into the atmosphere by the spiralling winds of a tornado. In the UK, twisters are surprisingly frequent. In fact, they get about the same amount as the USA. It's just that they're small and rarely do any damage.
Look at that.
All across Europe, the increasing amount of wild, wet weather is bringing terrible devastation. But the real danger is not in the amount, but in the speed it moves. This is Thurcross Dam on England's Yorkshire moors. The perfect place to demonstrate that water only a few feet deep can knock you off your feet. The force of water is always a shock, as this child and his rescuers found out. What it needs is speed.
We've got 14 tons of water escaping every second. So if that's going to hit you, it's the force of a couple of cars hitting you and it'll push you over. And that's what people don't realise. Water can turn from nothing to that in a very few minutes. All we've done is release pent-up force which water has. Flash flood water is very cold by its very nature, and it will not allow you to stand back up. And people try to swim against it. And that's it. They get cold, they lose feeling in their body, and the next step is drowning. It can knock over a car, move a building, and flash flooding is at its worst. So try and fight it is impossible. Even a metre deep, once it gets above your knees, that's it, you're finished. All water needs is speed and volume. Once it's got that, it has the strength of explosive.
With the help of our stuntman, we're going to prove just how powerful shallow water can be when it's on the move. It only takes an hour of heavy rain to produce a flash flood. It's this that can wipe out towns and entire cities.
Good luck.
Thanks.
See you later.
As the floodgates are opened and all that force is unleashed, the water begins to rise by an inch every 10 seconds. It's getting harder for the stuntman to stay on his feet. If it wasn't for the cables, he would have already been washed away. The water is only 3 feet deep, but is moving fast. It's also cold, and very quickly the body begins to tire. The water is so cold that no feeling is left in the hands or feet, making it hard to get back to a standing position. This is proof that just 3 feet of water flowing at speed can be deadly. If this had been real, the stuntman would have had no chance. The force of water in a river can be lethal, but magnify that 1,000 times and apply it to the ocean, and the results can be disastrous, as the residents of Hunstanton on the east coast of England learnt to their cost. On the 31st of January 1953, a severe winter storm moved in off the ocean and lashed the northern coast of Britain. The storm swept round the northern tip of Scotland and headed south. The icy gale-force winds grew stronger as they were funneled into the North Sea. The sheer force of the wind piled the waters up in front of it, causing them to surge like bow waves. Over 12 feet high, the waves crashed through the sea defences and ploughed inland, smashing everything in their path. This storm would be a killer, but it would produce a hero. US Airman Rhys Leeming was called in to help.
When we arrived on the scene, it was nighttime, and we didn't know the area, and you know, as I looked at this first street that they were talking about, people were down in these houses. You couldn't see the houses. You couldn't see. All you could see was this water. It was like being in the middle of the ocean, really. There was water everywhere.
The winds were gusting at over 80 miles per hour as Rhys struggled through the icy water, dragging a rubber raft.
I took the raft and went through the gate that was here and carried it all the way back to the house, and I could hear the people, but I couldn't see them. Obviously, these people were on the roof, and somehow I got them, and I just don't know how. I don't know how we got them down and into the boat. I walked up to this house. I get up to that doorway, and that doorway was open, as I recall, and I took 1 or 2 steps inside and felt something on my leg, and turned out it was the leg of a man, and it was a husband and wife. Turned out, I found out the next day, an elderly couple, and they had drowned, you know, almost immediately, I guess, when the seawall was breached. Sure looks different now.
At the town hall, local nurse Dot Smith was waiting in vain for survivors.
The first woman they brought in, I just didn't know what to do, because I thought, well, if she's dead, the others are. And sure enough, they were drowned. 2 children were brought in next, and I put them all together on trestles close to each other. And then the father was brought in.
By the time I got down to this area to get these people off, they had been certainly on the roof of those houses since 4 or 5 o'clock in the afternoon. This is like 11:30 at night, so with wind blowing 120 miles an hour, and they were soaking wet, and the rain and freezing water. You know, it would be amazing to me if out of the 27 or 30 people, whatever, that I got out, that all of them survived.
After 4 hours in freezing conditions, the cold finally took its toll.
I was aware late in the evening that I was freezing, that I was to the point where I just couldn't move my legs. And I remember thinking, oh boy, you know, you're in big trouble. And I had to hang on to the raft because I had these people in it. And that's the last thing I remember.
I said to the ambulance men, how long has he been like this? They said, well, we just fished him out of the water because his wetsuit he's wearing has got torn. And I said to the chaps, look, has anybody got these scissors? Because we've got to cut these legs off this wetsuit.
Somebody said his legs will have to come off. And that was really frightening because I thought, oh boy, this is bad news.
Despite his injuries, Rees had rescued 27 people. A week later, when news of his heroic act had spread, he was in front of the newsreel cameras reenacting it. In the days that followed, 60 bodies were recovered. Thousands of survivors now found themselves homeless.
I thought about these people. I got a letter from a woman, and she said, you rescued me and my 2 sons that night. And we've been trying to find you for 40 years. And she said, you'd be interested in knowing that the 2 boys, the 2 boys, one graduated from Cambridge and is a professor there now. And the other graduated from MIT, and he is a professor of mathematics at MIT. And so that was neat, you know.
I never did see Rees again, and I never heard from him from America.
Almost a lifetime later, Dot and Rees are reunited on the seafront.
Hi there, young lady.
Oh, my goodness.
How are you?
Oh, Rees. Oh, a beer belly.
Yeah, exactly.
How long is it? 53. 53.
53.
Yeah, when you were 19.
Yes.
And a slim little boy.
Slim little skinny kid.
Yeah, I know how skinny you were because I took all your clothes off.
Yes, I know. and you cut my pant legs.
Yes, around there.
And you said his legs have to come off. And
I didn't.
I
did not. I said the legs have got to come off.
Right.
Which meant the legs of the wetsuit.
Exactly. And for 50 years, I've lived with that fear. I've awoken in the night and remembered coming to and hearing somebody say my legs have to come off. And I thought,
yes,
cut
but
my legs
you
off.
weren't very well at the time, so
Well,
plus I didn't.
The memory still haunts the survivors, as does their shock at the awesome power the weather displayed that night. Fueled by water in its many forms, the weather can bring life and death. Hurricane Mitch washed away an entire country, whilst the Indian monsoon brought the land to life. The constant cycle of water that flows around and through us fuels the weather that dictates our lives. Back where the journey with water started, the people there have developed a lifestyle that is almost waterproof. Bergen, City of Rain. At the TV station, Benedict is still smiling through the forecasts. While out in the town square, these kids are at the annual rain festival. The love of a good shower is instilled at an early age. Life would be impossible if rain stopped play, so they celebrate it. But today, something's not right. It's not raining. Such is their thirst for the stuff, the local fire brigade have to be pressed into service.
We have a saying in Norway. It goes like this, there's no thing like bad weather, only bad clothing. So, I mean, on a wet day, the 4-year-old little Rika, she's got a great time. doesn't matter what kind of weather. They are used to it.
The key to life in a wet world is to learn to live with it, to love it. Without water's endless cycle around the planet, there would be no life at all. No weather, no sunny days, and no playing in the rain.